Hello, welcome to the Ham Radio Nomad. We are doing another practice session, or we are doing another test tonight. So on the screen, you will see my score from last time, 33 out of 50. You need 35 to pass, so two points missing. Um, Thank you, Anime and Gordon, Farmers Forage, for comments. And remember to subscribe and like, hit the notification button. And I am going to get started because it is a very full hour to get all the questions done and still have time to review to go through and do a quick review of which ones have I got wrong. What is the equation for calculating power dissipated by a series linear voltage regulator? A, input voltage multiplied by input current. B, input voltage multiplied by output current. C, voltage difference from input to output multiplied by output current. D, output voltage multiplied by output current. I'm going to guess C. I wish you luck, Gordon, on your retake. Question 2. What is a use for Wilson divider? A, it divides the operating frequency of a transmitted signal so it can be used on a lower frequency. B, it's used to divide the power equally between two 50 ohm loads while maintaining a 50 ohm input impedance. C, it is used to feed high impedance antennas from a low impedance source. D, it's used to feed low impedance loads from a high impedance source. I have no clue. I don't know. I'm just going to guess A. I have a feeling I'm going to be doing really bad and bad this week. A, why should HF and mobile antennas loading coil have a high ratio of reactance to resistance? A, to swamp out harmonics. B, to minimize the Q. C, to lower the radiation angle. D, to minimize the losses. I'm pretty sure it's D. You want high reactance to help get to the point where you need to be with in relation to the frequency, and you want low resistance because resistance is what changes the signal to heat instead of RF. What is one of the potential hazards of operating in the amateur radio microwave bands? A, microwaves can have, let me start over. A, microwaves have often travel long distance by ionosphere reflection. Nope, that's HF waves. B, the extremely high frequency energy can damage the joints of antenna structures. I don't think so. But let's see what the other ones are. C, microwaves are ionizing, and I don't know how to pronounce that, radiation. D, the high gain antennas commonly used can result in high exposure levels, and D sounds right. What is the radiation resistance of an antenna? A, the resistance in the atmosphere that the antenna must overcome to be able to radiate a signal. B, the value of resistance that would dissipate the same amount of power as that is radiated from an antenna. C, the combined losses of the antenna and the feed line. D, the specific impedance of the antenna. I'm going to go with C. What is the common use for point contact diodes? A high voltage rectifier. B, as a constant current source. C, as a RF detector. D, as a constant voltage source. I'm going to go with A. I know diodes are used in rectifiers. I don't know. It's something to do with point contact. I don't know if they're for high voltage or not. So, but I'm going to guess A. Which of the following receiver circuits can be effective in eliminating interference from strong out of band signals? A narrow IF filter. B, front end filter or preselector. C, a properly adjusted product detector. D, a notch filter. Notch filters aren't for out of band signals. I have a feeling it's either A or B. I'm going to go with A. Which of the following can be used to measure the Q of a series tuned circuit? A, the inductance to capacitance ratio. B, the resonant frequency of the circuit. C, the frequency shift. D, the bandwidth of the circuit's frequency response. I'm going to go with D because Q is related to the lower the Q, the wider the bandwidth. So because Q is related to bandwidth, I'm guessing it's D. How many times a second is a new frame transmitted in fast scan television system? I believe it's the there is 60 transmissions per second and there's two frames. Each transmission is half a frame, so I'm going to go with 30. What type of logic defines A as high voltage? A, assertive logic. B, reverse logic. C, positive logic. D, negative logic. I'm going to go positive logic. Which of the following describes a receiving filter? A receiving filter's ability to reject signals occupying an adjacent channel. A noise filter. B, a passband ripple. C, a phase response. D, shape factor. I'm going to go with shape factor. I think it's wrong, but well, Gordon, just for reference, if you're going for your foundation, I believe your foundation's your entry level. This test here is the amateur extra, which is the final level. This is the highest test. What is the current in the primary winding of a transformer called if no load is attached to the secondary? A, magnetizing current. B, excitation current. C, direct current. D, stabilizing current. Um, I believe it's either A or B. I'm going to go with excitation current. What is the deviation ratio of a FM phone signal having a maximum frequency swing of plus or minus 5 kilohertz when the maximum modulation of the frequency is? So Gordon is saying, is that the one about the, Gordon, that's D is the one about the um, transformer? You're saying it's a stabilizing current? What is the deviation ratio of an FM phone signal having the maximum frequency swing of plus or minus 5 kilohertz when the maximum modulation frequency is 3 kilohertz? Yeah, you're probably right. Now that you mention it, that sounds like it is likely the case. We'll see. I'm going to go. I'm going to go with 0.6. And yeah, Andy, you might be right. I have a feeling I'm going to be doing very badly in this. Welcome to the broadcast, Andy. Which of the following can cause shielded cable to radiate or receive interference? A, tying all ground connections to a common point resulting in differential mode currents on the shield. B, common mode currents on the shield and conductors. C, use of braided shielding material. D, low inductor ground connections on both ends of the shield. I believe it's B. Which of the following is acceptable bandwidth of DRM based voice and SSTV signals made on the HF amateur bands? 3 kilohertz is for single sideband, 10 kilohertz, 20 kilohertz, or 15 kilohertz. I believe it's 15. How is positive feedback supplied in Colpitts isolator? I remember several questions about Colpitts isolators. I don't really remember the answers. So I'll probably be getting this wrong again. Through a capacitive divider, through a linked coupling, through a neutralizing capacitor, and I'm going to go with D, through a tapped coil. Which of the following types of modulation is common for data emissions below 30 megahertz? Which 30 megahertz is the 10-meter band, so which is the below 30 megahertz is in the HF, what's considered HF bands. Above 30 megahertz is VHF. A, DTMF tones modulating an FM signal. That's not true. B, FSK, that's quite possibly true. C, pulse modulation, and spread spectrum. I'm going to go with FSK, frequency shift keying. What might be indicated by a sudden rise in radio background noise across a large portion of the HF spectrum? A, long path propagation is likely. B, solar flare. C, increased terrestrial propagation. D, temperature inversion has occurred. I believe it's a solar flare. What is the half power bandwidth of a resonant circuit that has a resonant frequency of 7.1 megahertz and a Q of 150? Oh, there's a formula for it, and I read it last time because I got this one wrong. Um, and yeah, so okay, so let's try this. I believe it is that. So yeah, if you divide 7.1 megahertz by 150, you come up with 47.3. So that's why I'm going to go with that answer. Which of the following frequency ranges is most suited for meteor scatter? I did UHF last time, and I was told that that's wrong. It is actually VHF. So I'm going to go with D. What is the time constant of a circuit having two 220 microfarad capacitors and two 1 mega ohm resistors all in parallel? And I don't know. I'm just going to go with so resistors in parallel divide. So that's going to be half a mega ohm resistance, and capacitors, I believe, in parallel actually add. So that's going to be 440. And then I don't know and then I don't know how the time constant between those two is affected. So I'm actually going to switch it to that one. Which one do you want read again, Gordon? I'm going to guess that one, but I'm not exactly sure. We'll find out the equation at the end. What happens to the linearly polarized radio waves that split into ordinary and extraordinary waves in the ionosphere? Okay. 21. I will read that. Go back to that as soon as I get done with this one. What happens to linearly polarized radio waves that split into ordinary and extraordinary waves in the ionosphere? They are bent toward magnetic poles. They become depolarized. They become elliptically polarized. They become phase locked. I'm going to go with elliptically polarized. This one, what is the time constant of a circuit having two 220 microfarad capacitors and two 1 mega ohm resistors all in parallel? So what I believe is the case is that when resistors are in parallel, the resistance is divided. So the 1 mega ohm is actually going to be, so the series itself is going to have a half mega ohm resistance, and capacitors in parallel add, so it's going to have a 440 microfarad capacitance. The question I don't know is how, once we know the capacitance and the resistance, what's the equation for the time constant? I'm not sure. How many watts are consumed in a circuit having a power factor of 0.6 and an input of of 200 volts at 5 amps. So 200, so that power is 2 times 5, which is 1,000, times 0.6 is going to be 600 watts. How does a radiation pattern of a horizontally polarized 3-element beam antenna vary with the increasing height above the ground? A, the horizontal beam increases. B, the horizontal beam decreases. C, the takeoff angle of the lowest elevation lobe decreases. D, the takeoff angle of the highest elevation lobe increases. No, the takeoff angle of the lowest elevation lobe increases. So a horizontally polarized antenna is like a dipole. This one is a 3-element beam. So I'm not sure of. You are quite possibly right, Gordon. I'm completely, I completely blank with regards to that equation for the time constant. So with a dipole, with a standard dipole, as you take off, as you raise it, the takeoff angle of the lobe decreases. I believe, because that's because inves is when you lower the dipole. So it's either going to be C or it's going to be one of A or B. And I don't know which. I'm going to go with C, that it's a trick question and it's the same answer as a dipole. But I could very well be wrong, and there's something specific with the fact that it's a 3-beam element which is kicking in A or B. What is a common method of generating a SSB signal using digital signal processing? A, varying quartz crystal characteristics emulated in digital form. B, signals that are combined by quadriculture phase relationship. C, a frequency synthesizer removes unwanted sidebands. D, mixing products are converted to the voltage and subtracted by adder circuits. I'm going to go with C. And Gordon is agreeing with me, so I might have actually gotten one right. How can intermodulation interface between two repeaters occur? A, when repeaters are close proximity and the signals cause feedback in the final amplifier of one or both of the transmitters. B, when the signals from the transmitters are reflected out of phase from air lines passing over. C, when signals from transmitters are reflected in phase from air lines passing over. D, when repeaters are close proximity and signals mix in the final amplifier of one or both of the transmitter. Okay, it's A or B. I'm going to go with D, or it's A or D, and I'm going to go with D. What is the bandwidth of a 480 hertz frequency shift and a 960 baud FM transmission? I'm going to go with C. They add together, and there's a mixing factor, where there's a transmission transformation factor of, I think, 1.2 or something, but they add together, and the only one that is possible when they're added together is C. Which of these materials is most commonly used to create photoconductive devices? A, a heavy metal, B, a liquid semiconductor, C, a crystalline semiconductor, D, ordinary metals. It's a semiconductor, and I'm not sure if I'm going to go with a crystalline semiconductor. Why does a PN junction diode not conduct current when reverse biased? A, holes in the p-type material and electrons in the n-type material are separated by applied voltage, widen the depletion region. B, only n-type conducting material can conduct current. C, excessive holes in the p-type material combined with electrons in the n-type material converting the entire diode to an insulator. D, only p-type semiconductor material can conduct current. The current is passing from one junction to the other, so I don't believe it just can't go in the reverse direction. So I don't think it's B or D. I'm going to go with C. Maybe wrong, but yeah. What type of modulation is used for JS65 contacts? A is wrong. That's internet protocol. B, RTTY. C, multi-tone FSK. D, PSK. I'm going to go with C, multi-tone ASSK. What? And that's, yeah. What feature of a cordial pattern antenna makes it useful for direction finding? A, a very sharp peak. B, a very sharp single null. C, broadband response. D, radiation angle. What's useful in signal finding is the null. So I'm going to go with a very sharp single null. Which of the following geographic descriptions approximately describes line A? A, line A runs parallel to and east of the Pacific. Nope. Okay, I'm just going to jump to D. Line A is the border that's like 100 miles south of Canada. That north of that line, you cannot use the lower part of the 70 centimeter band. What third family of circles is often added to a Smith chart during the process of solving problems? A, standing wave ratio circles. B, antenna length circles. C, coaxial length circles. D, radiation patterns. I don't. I'm going to go with D because I don't believe the length or either that, and standing wave ratio usually isn't circles. What is the characteristic of grounded grid of a grounded grid amplifier? Yeah, that's what I was thinking too. Um, Gordon. Grounded grid amplifier. A, high filament voltage. B, low bandwidth. C, low impedance. D, high power gain. Um, I don't know. I'm going to go with C, low input impedance. What type of wave does Fourier's analysis show to be made up of sine waves of a given fundamental frequency plus its harmonics? You're guessing C on 34 as well, Gordon? Oh, what type of wave does Fourier's analysis show to be made up of sine waves of a given fundamental frequency plus all its harmonics? A, sine wave. B, a sawtooth wave. C, a square wave. D, a cosine wave. Um, I'm just going to state probably trick, but I'm just going to stay with sine wave. So we have 3 people watching. Thank you for watching. Be sure to subscribe and like. And I am a little over, a fair amount over halfway. So I should be on pretty good time to, I'd like to get done with this at about 7:50, and then we'll take the last 10 minutes to go over the questions that I get wrong. No, I'm just going to go sawtooth wave. For some reason, they have sine wave in the question, so I don't think it should be in the answer, but maybe I'm wrong on that. What must the VE team do with an application form if the examinee does not pass the exam? A, return the application documents to the examinee. B, destroy the application form. C, maintain the application form with VEC records. D, send the application form to the FCC and inform the FCC of the grade. Well, the government wants us to maintain the form, maintain paperwork, but they don't necessarily want us to hassle them with it. So I'm going to go with C. 37. What is the advantage of including parity bits in ASCII characters? A, some type of errors can be detected. B, faster transmission rate. C, signals can overpower interfering signals. D, foreign language characters can be sent. I believe parity bits is for error detection. Which of the following displays multiple digital signal states simultaneously? A, logic analyzer. B, network analyzer, C, modulation monitor, D, bit error rate tester. I'm going to go with a network analyzer. Actually, no, I'm going to go with the logic analyzer. Digital is usually plus or minus. Digital values are usually displayed logically. So as plus, so I'm going to go with that. Which of the following is which of the functions of reactance modulator? What is the function of reactance of a reactance modulator? A, to produce AM signals by electrically variable resistance. B, to produce PM signals by using electrically variable resistance. C, to produce PM or FM signals by using electrically variable inductance or capacitance. D, to produce AM signals by the use of an electrically variable inductance or capacitance. I'm going to go with D. Why should effective radiated power to a satellite that uses linear transmitter be limited? A, to prevent creating errors in satellite telemetry. B, to prevent satellites from emitting out-of-band signals. C, to avoid interfering with terrestrial QSOs. D, to avoid reducing downlink power to other users. And yes, I am agreeing with Gordon that it is D. What point on the figure E5-1 best represents the impedance of a circuit consisting of a circuit with 300 ohm resistor and 18 microhenry inductor at 3.505. So A1.1, which is positive 300 and negative 400 Y. B7, I'll just say right off the bat, 7's wrong. 300 ohm resistor means it's going to be X value of 300. So it is C.3, which is plus 400 Y 300X, or D.8, which is 100. Sorry, it's about 50 Y and 300X. I've been getting these, so I know it's either 0.3 or 0.1, so it's either A or C. I've had this question, I believe, 3 times, and the first 2 times it was 0.1, and last time it was 0.3. And the difference is there's one question that has is an inductor, and the other times it's a capacitor. And conductors or capacitor, and it's a question of which one, capacitors or inductors, are is a negative imaginary number, and the other one is a positive imaginary number. And I'm going to go with inductor is negative, so I'm going to guess A, but I could be wrong. It could be C. What magnitude of voltage gain can be expected from the circuit in 7 E7-3 when R1 is 10 and RF is 470. Yeah, I'm just going to guess B. There is I've seen this a couple times. There's an equation for it, but I don't remember it. Which UHF amateur bands have frequencies authorized for space stations? And Gordon is agreeing with me, I believe, on 42 that it's 47. Which bands? I'm going to go with the only one we typically use, which is 70 centimeter. What is the permitted mean power of any spurious emissions relative to the mean power of fundamental emissions from a station transmitter or external RF amplifier installed after January 1st, 2003 and transmitting on a frequency below 30 megahertz, which is HF. I don't have a clue. I'm just going to guess A. What happens when the level of the comparator's input signal crosses the threshold? A, the IC input can be damaged. B, the feedback loop, it becomes unstable. Gordon, is that for this one 45 or is that for 44? Is C for 44 or 45? C, the comparator changes its output state. D, the comparator enters latch up. I'm going to go. Okay. So Gordon believes that the permitted power is 73 dB below. And actually, that was my other guess. That was my other thought because it's a maximum. It's a lowest permitted value of those options. So I'm going to go with for 45. I'm going to go with C. The comparator changes its output state. What is the disadvantage of decreasing the number of wire segments in an antenna model below 10 segments per half wavelength? A, ground conductivity will not be accurately modeled. B, the resulting design will favor radiation above harmonic energy. C, the computed feed point impedance may not be incorrect. The computed feed point impedance may be incorrect. D, antenna will be mechanically unstable. I don't really understand this question. I'm just going to go with Gordon. I don't understand it because of a dipole in theory is 2 wire segments, 1 in each direction. So it's way below the 10 segments per half wavelength, because it's, in that case, it's only 2 segments for the half wavelength. So that's, I don't understand that. I don't really understand the question. What impedance does a half wavelength transmission line present at a generator when the line is shorted at the far end? And this would be low impedance. I've gotten that wrong last week or the week before. It's, if you short it at the far end, it's basically doing, you're basically doing a full wavelength, one half wave there and one half wave back, so it's a full wavelength antenna, loop antenna. How should one generally identify your station when attempting to contact DX stations during contests or in a pileup? A, send only the last 2 characters of your call sign. B, send your full call sign in grid square. C, send your full call sign once or twice. And I'm just going to stop there because that's the right answer. Which of the following device packages is through hole type? A, ball grid array. B, DIP. C, PLCC. D, SOT. The only one I recognize, and that's why I picked it last time and I got it correct, was DIP. And the last question, where must the carrier frequency of a CW signal be set to comply with FCC rules for 60-meter operation? On A, on any frequency where the signal sidebands are within the channel. B, center of the channel. C, the lowest frequency of the channel. D, the highest frequency of the channel. And this one, for a 60-meter operation, everything is centered on the channel. So I'm going to go with B. And there we have time to grade the exam. This is, so last time I got 33. The time before that, I got 32. And this time I got 34. So I missed by 1 point this time. I improved my score by 1 point. And just a moment, I am going to just creating a screen grab of this a moment. And let's see. Yikes. I really did bad in that section, E1. So review the question. Time to review the questions. And for those that are watching, if I can keep track of which screen I am on, be sure to hit the like and subscribe button down below. Not a problem, Gordon. I'm the one taking the test, so. Okay. Okay, so what is a Wilson divider? Wilson divider is used in microwave circuitry to split the power coming into the divided into 2 output ports. It divides the power 50-50 between 2. So it's a Wilson divider is between two 50 ohm leads. What is the radiation resistance of an antenna? The value of the resistance, okay, it's the value of the resistance that would be dissipated by the same amount of power that is radiated from the antenna. Okay. Okay. So a point contact diode is a RF detector. Yeah, that's yes, Gordon. Yeah, you study for a different test. So, which of the following receiver circuits can be effective in eliminating interference from strong out of band signals? And it was again. So this is my problem. The same problem I had last week is I can narrow it down between the bad answers and the like I can half of these it's like okay I know it's like this one I knew it was A or B and I guessed B and it was actually A. So we need a pre-selector for strong out of band signals. And oh, so this one, Gordon, I believe you were saying it was destabilizing current. It is actually magnetizing current. Um, so it, that one magnetizing current when it is not when there is no load. And I believe you said this one was D. And yep, you're right. It is D. So it looks like this one is a straight 5 divided by 3, where I did 3 divided by 5. Uh, I was wrong. Okay. SSTV needs to fit in the same bandwidth as SSB. So it's anything that's in the HF bands should have the in most cases SSB is the standard. And I was figuring I got this one wrong with the Colpitts oscillator. Capacitive divider. That isn't good. Yeah, it's no fun when internet's not being nice. Think C for culprit, C for capacitor. Hmm. So this one was, I did get this one correct. So it is time constant is ohms times farads. So picofarads is added together. Um, resistors are divided, and then you times them together. Okay, so the beam antenna acts just like a dipole. So generating an SSB signal using digital signal processing. Signals are combined in a quadruple and I can't pronounce that, quadrature phase relationship. Um, SSB has a mathematical form of QAM in the special case where one of the baseband waveforms is derived from the other. Okay. Again, I knew it was an A or B. Okay. So with a diode, it creates a depletion region. Okay. Oh, yep. Again, I chose the wrong one. So Sandy wave ratios is added to the Smith chart. Okay. If the application, if the examinee does not pass, then the application is returned to the examinee. Okay, a reactance modulator is to produce PM or FM signals. Inactance and reactance affects the phase of a wave, not the amplitude. Okay. So it was the other one. So inductors are positive, capacitors are negative. And UHF for space stations is 70 and 13 centimeters. And this one is actually the highest one instead of what we were thinking was the lowest one for the permitted mean power of any spurious emissions. And that is all of them. I am running behind. Thank you for all who watched. It is time the for Tank Radio's live stream. So head on over there. I am pasting the link now. So Penny, the Tank Radio's doing a live stream right now. Head over there. I'm gonna go watch that while I grab something to eat. Enjoy his show. Thank you all for watching. And until we talk again, 73.